Well, I have spoken at PNSQC quite a few times in the past, starting around 1996, and so it's nice to be back. But um, when I was talking with Moss about doing this presentation, it occurred to me I should probably learn a little more about the conference this year, see what we should be talking about. So, and that's actually working. Okay. So I went to the website, PNSQC.org, and the first thing I saw was a graphic like this. And I said, oh, that's cool. You know, got a nice blue Fender Stratocaster, got an amplifier because we're going to amp it up. And that all sounded like fun. So I said, well, my first thought was maybe I should bring my own Fender Stratocaster and maybe my Les Paul and maybe my 100-watt amplifier and see how that works. But I live in the suburbs. I live in Happy Valley. And it occurred to me that getting all this gear on a Max train could be clumsy. So I decided no guitars today. Sorry. But if you go to karlwiegers.com, you can hear about 60 songs I've recorded. So that'll keep you amused. So then I looked a little further into what the conference was about. And I saw that there were some themes, some tracks. We're going to use technology and processes to amplify quality. Certainly seems like a good idea. In fact, we've probably been trying to do that sort of thing for many, many years now. And there was this track, or theme, processes and tools, methods, technologies, and so forth. Management, leadership, and people, an often neglected part that we all know is extremely important. Emerging technologies and concepts, which these days is pretty much all spelled with 2 letters, right? Okay. So I said, okay, well, what do we got around requirements? So I did a search for one of my favorite keywords, and here's what I saw: phrase not found for REQ. And I'm thinking, oh, I think I see a part of the problem, because as you may have guessed from the title of the talk, I think quality begins with requirements. So what I'd like to do this morning is share with you some thoughts about why that is and how we can do a better job with quality in the macro sense by doing a better job on requirements. So how might you start this in your organization? How many of you hold retrospectives in your organizations? Okay, maybe 3/4, which is good. And hopefully if we ask this question year after year, that'll turn into everybody's hand. Little side note here. The person who introduced the term retrospectives into the software vocabulary is a man named Norm Kurth, with his classic book, Project Retrospectives, from, I think, 2001. Norm lives about 4 miles from here. He's my closest friend, just a wonderful guy. And if you're interested in retrospectives, I highly recommend you check out his Project Retrospectives book. But the process has evolved since then, but still a lot of the principles and practices he describes are fully applicable and very valuable. So if you hold a retrospective, one of the issues that might come up is, gee, we had some issues. We had to do more rework than we anticipated. I don't know if any of you have ever had that experience. I mean, you're always going to do a certain amount of rework. Okay, it's a nature of our business, and it's not always a bad thing, but I hate rework. I hate doing over something that I've already done once. I try to avoid it, or at least minimize it. So if you find that you've had to do some rework, you might ask yourself why, and you very well might discover that some of the rework that had to be done was because of requirements-related issues. So now we have a perfect setup for doing some root cause analysis using one of my favorite techniques. Okay, in fact, I was talking to a friend of mine about publishing some books just a couple days ago. He had self-published some books. He was looking into maybe going to a traditional publisher and trying to move it up a little bit. And so we did a little root cause analysis over the phone. Like, so why aren't your books selling? Okay, let's start with that conversation first. And then we can start figuring out, once we understand the problem, what's a possible solution. So you might ask yourself, in a classic sort of fishbone or Ishikawa type diagram like this, why are we experiencing requirements-related rework? Out of curiosity, how many of you would say that that's an issue in your projects, requirements-related rework? Only a hand, well, about half the hands, but some people may not be quite awake yet. Well, there are a lot of reasons why this might happen, because it's a pretty common problem. Maybe we've overlooked some stakeholders, some people who have expectations, And when we finally do discover them, they show up and it's like, oh, we have to change something, we have to fix something, we have to add something, maybe we have to take something out. Maybe we have faulty memories. Human memories aren't very good. They're fragile. They decay with time. And other people can't access them very well. So I think it's a good idea to avoid the problem that also you may have had where you walk out of some conversation with different ideas of what's going to be done as a result. And then we zig when we should have zagged, and we end up having to fix it later. Or maybe we found the right stakeholders, but we didn't engage with maybe the right representatives or very effectively, or something that led to inadequate user interaction. Perhaps we're missing requirements, which could actually be as a result of any of these other factors. So sometimes, it's not clear which is a cause and which is an effect. Requirement changes are a pretty much standard activity. A lot of times we overlook some business rules. Sometimes business rules which affect every product are treated sort of as corporate folklore around the campfire rather than being documented someplace, and we might not be aware of some of them, or they might have changed from what we thought we knew. So you have this kind of conversation, could be invalid assumptions, and there could be lots of other factors that lead to having to do requirements-related rework that you didn't expect. Okay, I'm not talking about the planned rework of iterating things, but the stuff that we didn't think we were going to have to spend time on that. And then you go down to the next level with each of these. And this is the matter of asking why several times. So it doesn't have to be 5, but you have to ask why enough times so that you understand each of these contributing causes and the root causes to contribute to them. So now we think we understand the problem. And I always think that's a good way to start before you begin selecting solutions. So what can we do about them? Once we identify these root causes, what's the next step? And that's where I might be able to offer some suggestions. So there are a lot of books big books on requirements and business analysis that describe dozens, or in at least one case, more than 100 practices. And these are all useful practices to do in various situations. But not everybody wants to read a great big book. I've written some of those great big books, but some people want to read them, which is a good thing. But I've realized that you could distill down all of these practices into what I think is a core set of 20 requirements-related practices that I believe every project should consider doing. It's hard for me to see how these wouldn't apply to pretty much every project. And this is what we wrote about in my latest book, Software Requirements Essentials, co-authored with Candace Hokinson, came out a little earlier this year. So I want to show you today what those 20 practices are. And yeah, go ahead.
I think one of the requirements would be that we need to see that top title.
Okay. And that's different from what I see here, so I couldn't notice that.
Yeah.
That's very good observation.
So we all know it's Karl, so we don't need to know that.
Cover up that copyright notice.
But it would be
for that.
But it would be great to see the title.
Yes, thank you. See, this isn't WYSIWYG, right? I see something different than what you see. Thank you, Phil. So I want to talk about some of those practices today. I'm not going to have time to go into all of them in detail, but I want to call out some of the ones that have, I think, a particular impact on the quality of what we design and build. I'm doing a workshop tomorrow afternoon where I'll be going into all 20 of these in some detail. So the 20 practices, okay, so now, there we go, are grouped into 6 categories. Laying the foundation for success, there are 5 practices for that. 4 practices on requirements elicitation, because these are now the 5 subdivisions of requirements engineering. 4 on elicitation, 4 on requirements analysis, 4 on requirements specification, which basically means recording in some form whatever we've learned. 1 practice for requirements validation, and 2 core practices for managing requirements, whatever you do with them once you have them. So I'm going to share with you what these 20 are, and we'll pick out 1 or 2 in each category to drill down into. Sometimes people sort of gloss over some of the activities that really lay the foundation for a successful adventure. And I kind of building on the root cause analysis discussion we just had, I firmly believe we ought to start by understanding the problem before we decide on a particular solution. Have you ever seen a case in which people built some software with the best of intentions, and or maybe just a portion of it, and realized they weren't solving the correct problem, and they were solving some other problem that was perceived, and so you end up with a case where you've created something that doesn't really address the real need. Well, we want to try to avoid that. So I think it's a good idea. Never assume that a presented problem or a presented solution is necessarily correct. So some root cause analysis and asking why a few times is a good way to make sure we're addressing the right issue. People want to know why we're working on some initiative. What are we trying to accomplish? How do we know when we're done? And so defining business objectives early on helps align everybody towards a common successful outcome. When you first define some problem or some solution, you may not know exactly where to draw the lines between what's in and what's out. And so we want to define the solutions boundary. That's the third key practice here. And that helps us make sure we know what we're going to be working on and what we're not going to be working on. Otherwise, you end up with this scope creep where you just keep adding more and more stuff, or people are confused about what they are and aren't supposed to do. So this is really a scope definition activity. As you do these other things, you're going to begin to identify stakeholders. And I think we need to cast a very large net for potential stakeholders who could influence the project or derive some benefit from it or merely participate in it, because we need to make sure that we don't overlook some community who has important expectations, important needs, and important constraints. We need to be aware of the constraints that certain stakeholders impose. And the fifth category is to deal with the reality that we've got a lot of decisions related to requirements that we have to make on a project. There's all kinds of questions about priorities and conflicting requirements, and this group wants this, but they want that. What do we do? There's a lot of questions you have to face, and so we need to identify who those decision makers will be, preferably before they confront their first significant decision. And along with that, it's a good idea to identify a decision rule. How will each of these groups make the decisions that they do? So I want to talk a little bit more about this issue of defining the business objectives, because I think that's a very fundamental quality-related activity. We first run into a problem that occurs in every course I've taught. I've taught primarily over the last 25 years, one particular requirements course called In Search of Excellent Requirements. It's normally 2 days, sometimes shorter, sometimes longer. I have taught that course personally 187 times. It's not real exciting anymore for me. And I've given many, many other talks on requirements. And one thing I found is that the first concern you encounter whenever you start discussing requirements is merely terminology. People have different ideas of what different requirements-related words mean. So when I say begin with the business requirements, sometimes people interpret that term business requirements to mean any information the business tells us, anything they say they need. But I'm using the term here differently. To me, business requirements really get to the issue of why are we undertaking this project? Okay. What are we trying to accomplish with it? Why is it of value? How will the world be better once we build this product? So we might start with a problem statement. I've got a nice little template for a problem statement that says, here's some things to think through about what concern we have. Is there an opportunity to exploit? Is there something that's preventing us from achieving our business objectives, or what? So what are those business objectives exactly? What is the outcome that we're seeking that will tell us, oh, we've been successful? And how would we measure that? What metrics can we identify that will tell us if we've accomplished what we set out to accomplish, or at least give us an indicator that we're moving along the right path? All of this can lead to a solution concept. And you'll notice that that's not the first item. A lot of times people like to start with a solution in mind. And you got a great idea for a product that the world's just going to love and you'll be a billionaire. And sometimes you're right, but more often than not, I prefer to think through the other sequence and come up with a solution concept in that I feel confident is there for a reason. Another important part of this is called scope and limitations. I like that phrase. My background is chemistry. I have a PhD in organic chemistry, which I've always thought was the perfect background for anyone in IT. It appears to be a minority viewpoint, but it worked for me. And as an organic chemist, if you invent some new reaction that changes chemical type A into B, you write a paper, and one section of that paper is always called scope and limitations. What does the reaction do? What does the reaction not do? Okay. And I think we need to draw those lines when we're talking about a software project as well. So how does any of this contribute to quality improvements? Well, one very important outcome is this helps us identify the stakeholders that we need to engage. Okay? There could be a lot of them. There could be many more than you think, some more important than others. This lets us work with the right people to understand the functionality we have to build in order to create a solution that lets people do what they need to do and along the way achieves our desired business outcomes. How do you prioritize requirements? Well, there are a lot of techniques for doing that, but really what it boils down to is figuring out what do we do first, what do we do second, and what do we maybe never get around to that seemed like an important idea, but we're not going to do it for one reason or another. Well, one good criterion for doing that prioritization is based on how they contribute to achieving your business objectives and in what sequence. And this all hopefully helps us avoid the unpleasant outcome of having a successful project, but a product that fails. Okay, that's really not a very good endpoint to reach. So defining business objectives, I think, is a way to help lay the foundation for building a high quality solution, no matter what you're doing. Well, a very good way to start with working about requirements is to get some. And so requirements elicitation is a pretty important activity. People often talk about gathering requirements, and I don't like that term. I try not to use it because it sort of implies that you're walking around with a basket looking to collect them, like you're picking flowers or hunting Easter eggs or something. And there's certainly an element of collection, but there's more to it than that. It's not just collection. There's a lot of exploration involved. You're discovering requirements, and you're inventing some things. You know, people come up with ideas that they think would be useful and see if anybody agrees. So elicitation is a better, more inclusive term than gathering requirements. And there are a lot of places requirements might lurk, a lot of rocks you need to pick up and see if there's some requirements squirming underneath that you should assemble. There are lots of stakeholders, user representatives, subject matter experts, variety of other kinds of stakeholders who are going to tell you things that you need to know about. There are existing products, perhaps, or previous versions or something, or competing products if you're in the product marketplace. So a lot of places that you need to look, all sorts of documents that could be useful. And there are a lot of techniques that you can use for elicitation. You know, an experienced business analyst has this whole toolkit of methods that they can use to go hunting for this kind of information from various sources. Interviews are probably the most common, but workshops are popular, and you can learn a lot by looking over people's shoulders as they do their work. So we have to use a whole bunch of techniques to try to make sure we haven't missed anything. So there are 4 core elicitation practices that we describe in this book. First of all, we need to understand what users are going to do with the solution. I think that's really important. All products respond to some kinds of events that take place in their environment and generate some reaction. There are business events where someone or something outside the boundary of your world issues a request that leads to some action, often by triggering a use case. There are signal events where there might be an input from a sensor or some device, or perhaps you hit a certain data condition. There are temporal or time-triggered events, such as, hey, if you haven't received a payment from the customer from the guy who took a loan, by 30 days, then you send them a reminder notice. Okay, so that's a time-triggered event. So event analysis is a useful elicitation technique. Software exists to process data, or looked at another way, data is the glue that holds all the process activities within an application together. So looking at data concepts and relationships is really important, and data modeling is a powerful tool for this. Beyond functionality, which is what people very naturally focus on during requirements discussions, we have to consider a wide variety of quality characteristics about the product. We've all used products that did what they were supposed to do, but you didn't like them because maybe they did it too slowly, or they were unreliable. Like the Apple CarPlay in my Honda works most of the time. And every once in a while, it stops. I'm just driving down the road, using my phone to navigate or something, and the screen goes dark. The phone may still be talking to me, but no longer through Apple CarPlay. And I didn't do anything. As far as I can tell, nothing happened. Every once in a while, both of the display screens in my car just go totally berserk, but only when my phone's plugged in. But when it works, it's really nice, right? So those kinds of issues like reliability are pretty important. So let's take a closer look at these two practices, number 6 and number 9. I wrote a book a few years ago called Software Development Pearls, which described 60 lessons I've learned since I started programming in college 53 years ago, which hardly seems possible. And somebody asked me once, what's the most important lesson you've learned in your career? And I thought about it, and this is it. There are 2 ways you can approach a product specification or exploration. You can take a product-centric approach where you think about the features and what it's going to look like and that sort of thing. Or what I think is better is you take a usage-centric approach in which we consider what will people want to do with this. And from that, we can then derive the necessary features. So I recommend this usage-centric approach over a product-centric strategy in just about all cases. Instead of focusing on the functionality people say they want, let's focus on what people need to do with that solution and figure out what functionality will let that happen. This helps make sure that you implement the right functionality instead of putting in a bunch of features that seem like a good idea, and yet there's some things people still can't do with it. That's not good. The 2 techniques that are used most commonly for exploring these kinds of user requirements are use cases and user stories. And I'm a big fan of use cases. I find them to be a very natural way to work with potential users to understand kind of their mindset about what they're trying to do and maybe even see how they see that working. Agile projects tend to use user stories, and provided the user stories are focused on goals and what users need to do, as opposed to on little fragments of functionality, I think that's fine. But I think too often, in fact, by definition, early definition of user stories, they're pieces of functionality that people want for some purpose. And I'd like to step away from that, step back, and let's understand what the purposes are first, and then figure out the functionality. People very naturally, when you're having these kinds of conversations, focus on how things work in the normal, best behaved, default, nothing weird, no errors kind of situation. The normal flow, sometimes called the happy path. That's a very natural place to start, but we also need to explore alternative ways a user might want to accomplish a particular task. And very importantly, we need to think about exceptions. People who have done programming know that programmers spend a whole lot of time dealing with things that can go wrong, figuring out how to detect them, prevent them, recover from them, and so forth. And we want to start those conversations at the requirement stage rather than fixing them one at a time as people encounter them in real life. So there's a lot of quality payoffs that come from this practice. This shows us what functionality we need to build. So in this model that I advocate, if we start with some use cases that help us understand the tasks people are trying to accomplish, and that can be a fairly rich template that contains a lot of information to fully describe a use case, then a business analyst can examine that and start extracting what functionality must we implement to let that happen. What are the detailed requirements that will be necessary to fully realize that use case? This is a good way also to help align that functionality you implement with usage objectives and correspondingly with business objectives. So that alignment kind of down the hierarchy of business requirements, user requirements, functional requirements, I think that alignment's extremely important so that you don't end up building the wrong thing or missing something. Have any of you had the experience where people told you there's certain functionality that they needed, you built it, and virtually no one ever used it? Yeah, I think we've all seen that. In fact, various studies have shown sort of horrifying numbers about the percentage of features in commercial products, and I'm sure, internal products as well, that are rarely or never used. And the numbers range from like 50 to 80%. I mean, how much of Word do you use? Somebody may use some of them, and maybe somebody uses all of them, but most of us use a small subset. So I have had that experience. People said, okay, we need this. So you build it in. And as far as we could tell, it was never used once. And, you work just as hard on those parts as on the parts that people actually do use. So it's kind of frustrating. We want to try to avoid that. A usage-centric approach versus a feature-centric approach helps reduce that problem. So there's all these attributes that are characteristics not of what the product does, but how well it does it, how well it meets our expectations. Sometimes they're called quality attributes. Sometimes they're called quality factors, quality of service requirements. Some people lump these into just non-functional requirements. So I call them quality attributes. And there are two categories of those. There are elements of internal quality that are more important to developers and maintainers. Things like efficiency of use of resources, or how easily we can modify it when we need to, and could we port it to another platform, that sort of thing. Users are more interested in external quality characteristics, which is what people often think about when we consider the ilities, as they're sometimes called. Is it available when I need to use it? How quickly does it respond? How well does it handle unexpected conditions? That's what robustness is about. I've seen lists of 50 or more of these attributes. And probably most projects, maybe if you're building a space station, but most of us aren't building space stations. So you probably don't need to consider all 50 or so. But there's probably about 12 to 15 that you ought to ask yourself about. And these are the most common ones. And not only is this important from a requirements solicitation point of view for quality, but it really improves the user's experience when we get this right. I've seen many people write or attempt to write definitions of software quality, or any kind of quality for that matter. I'm sure you've seen a lot of these definitions. And I've never seen one that was fully inclusive and concise, okay? Because there's a lot of dimensions to quality. There's many aspects of it. These are some of the dimensions. There are others, of course. But exploring this helps us understand what, to our users and customers and other stakeholders' satisfaction, quality means in the context of a specific solution that we're building. By understanding which ones of those are most important, we can help people make the various trade-off decisions that are necessary. That's one of the problems, is that you can't ideally optimize all of these at once. You can't do it. There are trade-offs that have to be made. For example, if you're trying to make something that's going to be very portable, you might have to sacrifice efficiency in some respects because, it works different ways in different platforms, that sort of thing. So we wanted to understand the user's expectations around these so that we can specify them in a way that's quantitative, verifiable, and precise. You can't just say, oh, the system shall be secure. Well, yeah, of course, we all think that's a good idea, but that's not really a useful requirement. There's a whole lot of conversations, a whole lot of specification that takes place after that. And then you can design the product so as to achieve these quality goals from the outset instead of just hoping you can patch it in later on. You can't just write down some architecturally sensitive expectation, like say around scalability. You don't write that on a story card and get around to it whenever it pops up in the queue. You can't do that. It's a lot better to design these characteristics in from the beginning. Requirements analysis is something that's always struck me as kind of interesting because it's rarely defined. What exactly does requirements analysis involve? What's it mean? In fact, when I was working on this new book, I went and I looked at a bunch of other existing books on requirements and business analysis, and some of them didn't even have the term requirements analysis in the index. But I'm sure they talk about some of those things. So I thought that was curious. So really, at its heart, requirements analysis means taking whatever actions will ensure that all stakeholder needs are understood and recorded or documented in some suitable form, okay, so that people can act upon them. And then the next step is to ensure that we could design, agree upon, build, and test an appropriate solution that will meet those needs. I mean, that's really the essence of requirements analysis, bridging from specification to from elicitation into recording things for specification and then letting people, start building stuff. And note, when I'm talking about requirements here, I'm not saying you have to get all the requirements for the entire product before you build anything. We all know that doesn't work very well. But for every chunk you build, I kind of like to understand the requirements before I start building the chunk. So the requirements analysis process involves really more than anything learning and understanding, asking questions to confirm our knowledge, to fill in gaps, to try to detect missing information, which is hard. It's not there, it's invisible, so it's kind of hard to see. To try to refine our knowledge to an appropriate level of detail so that people can say, all right, I can figure out how to maybe build something that'll do that, and so forth. So it's an iterative, incremental kind of process. And there are 4 core analysis practices. First one was just to analyze requirements, both individual requirements and sets of requirements that have some relationship. And in the workshop tomorrow, I'll talk about 10 specific techniques to analyze individual requirements and 8 to analyze sets of requirements. I'm a big fan of requirements modeling, okay? One of my favorite topics. When I took a class on Jordan structured analysis and design many years ago, it totally changed how I approached thinking about building software. I'd never thought about the idea of drawing pictures to understand what you're doing before you actually started designing the code. And that was really powerful. Many people create prototypes. A prototype is a partial or preliminary or possible solution, which you can then evaluate, get some feedback from people to see if we're on the right track and find places where we need to do something a little bit differently. So that's a real valuable technique. And of course, the fact is, people can't build all the requirements at once, no matter how good or how important they are. You have to do things in some sequence, and so that's why prioritization is important. And one thing people don't like about prioritization is that sometimes it means you're not going to get something. Okay, that's sort of what low priority means. And people play a lot of games with prioritization. I've been at companies where people told me about some of those kinds of games where, everything would be prioritized at 90%, or 90% of it would be high priority, I should say, because they know if they said it was low priority, they wouldn't get it. Well, yeah, that's the whole point. Is that if you can't get everything, wouldn't you like to make sure that the parts you don't get are the parts that are less important or less timely? Yeah, I think so. A lot of people use a 3-level scale: high, medium, low. And one company told me, our scale is high, super high, and incredibly high. Well, that's just kind of like changing your speedometer to make you think you're going faster than you're really going. It doesn't really change anything. But prioritization is an important analysis activity. So let's look a little more at modeling. As I said, one of my favorite techniques. One reason modeling is valuable is because it gives you a different view of requirements than, say, a textual representation. There are a lot of views of requirements, a lot of ways to represent requirements knowledge. And when we think of writing requirements, we actually think of writing natural language text, because that's how people communicate. But the models give us different perspectives. And when I first learned about modeling, I tried to think of, okay, what's the one picture that'll show me everything I need to know about my system? And there isn't any. Okay. I was very sad to discover that no one picture will show you everything. You need to look at it from different points of view. You need to think about, one level, what are our objectives and how do they interconnect? What's the ecosystem in which our solution will fit? What are the various process flows? That's one view. There are features that you might want to draw a picture of, where you subdivide the features into smaller bits that you can implement individually and grow into a full implementation. You might want to model data, you might want to model states. There's a lot of different ways to look at different aspects of the solution. And this is useful because models sometimes communicate more effectively than text, partly because we have different audiences. Some need to see the details, some need to see big pictures. Some need to be able to drill down into the details from a big picture. So using appropriately selected models really helps you communicate more effectively with your various audiences. More often than not, I find models represent information at a higher level of abstraction than does text. And that lets you step back from details where you can get lost in just a sea of details and see how pieces fit together. So I think there's a huge quality payoff from modeling. One key to success in software development is iteration. Okay? But it's a lot cheaper and faster to iterate on pictures, on drawings, than it is to iterate on code. It's cheaper to iterate on concepts than to rewrite code. So modeling helps you bridge the gap between a bunch of conversations and the actual code. If you draw models using standard notations, which I highly recommend, please do not invent your own notations. There are lots of kinds of modeling conventions out there that are well established to show all sorts of things. And I think you're much better off to use one of those or a group of them, instead of drawing your own picture, because people don't know how to read your picture then. And it's a communication tool. So we need to speak the same language. But these have rules so that if you draw a picture and it gets validated against the rules or syntax for those kinds of models, sometimes you find problems. If you draw a data flow diagram and you've got a process with flows going in and nothing coming out, you kind of wonder what that process is for. So validating the models is very helpful. Pictures sometimes show you problems. They reveal problems more readily than does text. I once reviewed for a client a big requirement specification for a piece of hardware, a piece of equipment. And they had at one point in there a table that spanned about 3 pages, a big event table that said, okay, here's a bunch of events that can take place. Here's the state the system's in when that event takes place. And here's all the stuff that happens afterwards. It was pretty comprehensive. How did I know if it was correct or not? So what I did is I stepped back from all those details and I drew a state transition diagram so that I could see just boxes and arrows that showed these various states and the navigation pathways between them and what would trigger one navigation. And by doing that, I found errors that you never would find from reading 3 pages of text. I found places where a change of state was inappropriate. I found a state you couldn't reach. That's kind of important. And so by drawing the picture and losing the details and the distraction of the details, you can find problems more readily. One of the interesting things about creating multiple views is this. If you create only one representation of any kind of knowledge, but let's say requirements, one view, whether it's just a picture or just a list of requirements or just a stack of stories or just a bunch of acceptance tests, if you create only one view, you must believe it. That's all you have. You have to trust it. But if you create more than one view, preferably with entirely separate brains following different thought processes, you can then compare those. And a lot of times you'll find problems that way. You'll find ambiguities or conflicts or omissions, assumptions people made. But if you only create one view, you have to believe it. There's an old saying attributed to various sources that anytime the map and the terrain do not agree, you should always believe the terrain. That makes sense. But there is no terrain when it comes to requirements. They're all maps, and you don't know which one to believe. So creating more than one map then lets you help come to that understanding. So requirement specification then is the process both of recording the knowledge that we've acquired through all these activities, and that same term refers to the deliverables that you create with that information in it, such as a software requirement specification. And here we have a very early business analyst writing one of the very first requirement specifications. Actually, I think that's Charles Dickens, but close enough. So I want to suggest that whenever you see the phrase writing requirements, you mentally translate that into representing requirements knowledge, because there are many forms in which you can represent requirements knowledge. As I suggested, certainly natural language text is the most common, but it's not the only one. So when you collect these specifications in some form, there are a lot of ways you can do that. There's really just a container. When you talk about a requirement specification, people naturally think document's bad, so don't do that. Well, no, it's a container. It just holds some information. And these containers can vary in what kinds of information they hold, in how that information is structured and organized, what forms are used to represent it, that is, those various views, how much detail it goes into, and how rigorously formal it's presented. But they're all just containers, and whatever works for you is fine, provided it gets the job done, provided the people who need to do the work based on that information learn what they need from it and all get the same understanding. Because our goal for requirement specification, and really all of the work we do on requirements, is clear and effective communication. There's no other goal. That's what we're trying to accomplish, and there are a lot of ways to achieve that. And some people don't like to write requirements, okay? But I have little patience with that, because I believe the cost of recording knowledge is small compared to the cost of acquiring that knowledge. The hard part is not writing requirements. The hard part is figuring out what they are. Recording it is relatively simple from that. So documented requirements constitute a form of persistent group memory, which helps overcome some of the limitations of relying on individual memories. So there are 4 core specification practices. We might want to write our requirements in consistent ways, organize them in some structured fashion. Business rules are a really important topic. I mentioned a little bit earlier. Business rules are things like policies and laws, and computational formulas, all of which affect who can do what with our product under certain conditions. So let's make sure we identify and document the pertinent business rules and tie them to the bits of functionality and use cases to which they apply. And because of this goal of clear and effective communication, it's important that we all understand terms in the same way. So a glossary is a valuable component of requirements documentation, or really just project documentation. You want to watch out for terms that maybe have a local meaning and some an everyday meaning, and then some specific meaning within the context of your business, say. You want to watch out for terms that are used in multiple ways, or that are overloaded and mean different things. A printer is both a device and a human being who prints something. Okay? You don't want any confusion. I was at a company once where I reviewed a spec, and the guy who wrote it had sometimes talked about chemical samples. It was a piece of analytical chemistry equipment. Chemical samples, and other places he talked about runs, sort of just sprinkled throughout. And I asked, well, what's the difference between a chemical sample and a run? He said, they're really the same thing. And I said, well, all right, pick a term and stick to it, and then put the definition of the synonym in the glossary. But a requirements document is not a place where you want to creatively vary your language in an attempt to keep the reader's interest. Okay? That's great for fiction, but I used to make the joke that I hadn't written any fiction since my PhD thesis, but I actually wrote a novel a few years ago, so I can't use that joke anymore. Writing the novel was the most fun of anything I ever wrote. It was cool. But for now, I'll just tell you about writing requirements in consistent ways. What do I mean by that? We've got all these ways to communicate, and so you want to choose the techniques that will communicate most effectively to your various audiences. Certainly, we've got natural language text, but sometimes things work better when structured in a different way. You might use tables or decision tables. I love decision tables. Or screen sketches, not necessarily to say build it thusly, but to say, here's kind of what we're having in mind. But I saw a great example of this in one requirements document I reviewed. There was a pattern of 12 functional requirements, and they were fairly long and involved, 4 or 5 lines each, so it took up a page with the 12. There were 2 variables that changed among those requirements. So three possible values for one variable, 4 possible values for the other, 12 possible requirements. They had 12 requirements, but one of those combinations was missing, and one was duplicated. And it's really hard to find that by reviewing them, because first of all, it's boring to read through this set of 12 very, very similar things and pick out those subtle distinctions. And second, you just don't remember the previous ones you read for the most part. So it's hard to see. Now, if they had said, okay, here's a template pattern for this set of requirements, And here's the values for the 4, and here's the values for the 3, and you do it in a tabular form, problem solved. You can't end up with a duplicate or an omission that way. And if one of the combinations just doesn't logically apply, you can just say so in the table. Okay? I think that's a nice, simple approach. So there are various patterns that we can use for writing kinds of information. One common thing we think about is writing it from a user's perspective versus a system's perspective. Either one is fine. Okay, we just want to communicate clearly. I wish I had time today to talk about this technique called Planguage, which was developed by a guy named Tom Gilb, who's always 10 years ahead of the rest of the software industry in his thinking. It's a really useful technique for documenting non-functional requirements of many kinds. And whichever method you choose, the goal is to favor clarity over purity of style. You know, nobody's going to come along and make sure that you followed every rule, at least they better not, you know, every rule and that you did them all exactly the same way. We want to understand through clear communication. And the reason this is valuable to set these patterns is that, remember, different communication forms are more readily absorbed by different kinds of people. Some people are more visual learners. Some people prefer to read or watch videos, even cat videos, I suppose. If you write requirements in a consistent style using these patterns, people know what to look for. They know what information they can expect to find as they're looking through these. And by precisely specifying quality-related requirements using a technique like Planguage, you can do a much better job of creating designs that are both achievable and cost-effective, so you don't end up over-engineering something, say. So the next practice is validation, and their next subdomain of requirements, really. And you've got these requirements now. We've done some elicitation, we've done some analysis and specification, we've worked with a lot of stakeholders. So you have a set of requirements, but how do you know they're the right requirements? That's what requirements validation is about, confirming that the requirements we've accumulated do, in fact, accurately describe the needs of our various stakeholders, and confirm that the solution that we're conceiving and specifying would satisfy those needs to the best of our understanding and would achieve the business objectives that we set out in the first place. So we want to make sure we're building the right stuff. And of course, I hardly need to share with this community the difference between verification and validation, since you're all in the quality business, but those terms are so commonly misused and confused. I threw it in here. So verification means confirming that whatever you did was done correctly and to whatever was specified for it. Validation says whatever you did was the right thing to do, or whatever you plan to do is the right thing to do. And there are several ways to do this. Of course, one way to validate your requirements is to build the product and then put it out there and see if people say, yeah, that's it, or not. Well, that's kind of expensive. So you can take incremental steps. You can do prototypes, you can do incremental early releases and get feedback on those. Certainly, that's all valuable, but you still have to build something, and that's a little more expensive. So one of the core validation practices that I think is really valuable is to review and test the requirements. We have just that one kind of combo validation practice. So let's talk about that. So one of the phrases we hear at this conference and other places is the idea of pushing quality to the left. And this is where requirements validation activities really fit in. If you take kind of a traditional linear approach, you initiate some development cycle, could be, you know, 2-week iteration, could be the whole project, doesn't matter. And we deliver it at some point, and traditionally we would do a lot of testing and rework at the end. You know, I always kind of laugh when I see a project plan that has test and then move on, or review and then move on. That has never been my experience. It's been test or review, fix, retest, review, then maybe move on. So I like to see rework included as a specific task in any kind of plan. And if there's some time when you don't have to do rework, you're ahead of plan, which is allowed in every state and many foreign countries. So what I'm suggesting here is, by pushing quality to the left, is that we're going to reallocate some of our review and testing effort so that we do some of that on requirements early on, and then we have less to do later on, because we've already fixed or prevented a lot of potentially expensive issues, which should lead to shorter, quicker delivery. So reviewing requirements is, I think, a really important quality practice. I've been a fan of peer reviews for a long time. In fact, I wrote a book on that because I thought it was so important. And of course, in a review, we're getting people who are colleagues of whoever created some deliverable to look at it to try to find ways to improve it. And one thing we need to do to have effective requirements reviews, or really any reviews, is to select the right participants. So how many of your teams routinely do peer reviews? Not nearly as many hands as I would like to see, particularly at a quality conference. There's a message here. I think peer reviews are really important. And if you're not doing them, you might look into that, or at least wonder why we're not doing them. They're very strongly culturally dependent as well. I mean, it's an interpersonal activity. It's not just a technical activity. And that's hard for a lot of technical people, but it's doable. So you don't want to just have any random people look over something. If you've got a set of requirements, we want to choose some participants who perhaps include, sorry, one too quick there, include both the author and some peers of the author, maybe a business analyst and some other business analysts. But we also, we can't review these things in a vacuum. They might look great, but how do you know they're solving the right problem? So whoever created something that led to creating those requirements, could be customer representatives, could be a higher level system specification author. Let's have them review and make sure the translation was done correctly. And then whoever's going to have to do work based on that deliverable, I call them the victims of the requirements, they should review it too, because people like testers and developers and designers and architects are all going to find different kinds of issues. There are a lot of ways to do reviews, and you need to choose an appropriate level of formality and rigor depending on risk, really, depending on how likely it is that there are problems remaining we haven't found and how severe of an impact those problems could have. So with low risk material, you can use very quick informal reviews. Just ask a colleague to look something over for you, or a group of colleagues. But for higher risk material, I think it's valuable to do a more formal inspection. Do any of your organizations do inspections? I see one hand. Well, thank you for that. I think inspections have kind of died out, which I think is sort of unfortunate, because particularly for requirements, the inspection process is a way to reveal things like ambiguities more effectively than just an informal review will. If we have a checklist that identifies common kinds of requirements errors, that helps us know what to look for. So the quality payoff here is that catching errors earlier is much cheaper than finding them later. I think we all know that. And so I think also requirements reviews provide the highest review cost leverage because we, head problems off at the pass. And as I mentioned, having inspections, that particular process will help you find ambiguities that, if you just asked a bunch of people to review something and there was a requirement that made sense to all of them, but it meant different things to some of them, you got an ambiguity that you didn't catch, and inspections can maybe find that. I learned a long time ago that, and it was a real eye-opener for me, is that you can start testing as soon as you write your first requirement, because writing requirements is kind of a complementary thought process to writing tests. In one case, we're saying, build this. In the other case, we're saying how to tell if we built it correctly. Okay? So that's two different ways to look at it, two different views of the requirements knowledge. Now, on Agile projects, people often write acceptance criteria, which then details out, the essence of the story using a pattern like given, when, then, which helps us, have a structured way to understand tests. And the quality payoff from doing this early conceptual testing of requirements, did I mention that catching errors earlier is far cheaper than finding them later? Same phenomenon here. And if you have different people doing these two different thought processes, you can find ambiguities, you can find gaps in their knowledge, you can find assumptions that people made differently. And this is not wasted effort. Some people don't want to do that early test work because they see it as duplicate. Well, no, it can grow into specific test procedures and details over time. Another thing you can do with tests is to validate models. So let me show you an example here. Here's a fragment of a process flow, which deals with a case in which it's a website where sales representatives on the phone with a customer and they're filling out an order online for the customer. And one of the scenarios here is that given that the cart is empty, in other words, let's say that none of the customer's products they wanted to buy were available. Okay, so given that the cart is empty, when the author says, well, okay, you don't have anything I want, I'm not going to order anything else, then what should happen? Well, the process should terminate. Well, if we look at this process and try to trace the process flow with a highlighter pen that would cover this scenario, you can't do it. This says, okay, let's see if my pointer's working here. The item was in stock. No, and here we cycle around. There's stuff off screen here. Then when it's out of stock and then we don't want to order anything else, this says, well, let's send the final quote to the customer. Well, no, the test says the process terminates, and we can't do that. This model does not let us accomplish that test. So what's wrong? Anytime you find a disconnect between two representations, you don't know which one's right. You have to figure out, well, oh yeah, this one's right. So we decide the test is correct because that makes more sense than sending an empty quote to somebody. So we can make a change. We can fix the model, and we can fix any requirements somewhere else associated with the model. So we change our model to say, well, if there's nothing in the cart, let's check that first. If there's nothing in the cart, then the process ends. Otherwise, we'll send that quote all off to the customer. And we've got the same test now, and now we can walk through that and get to the desired end state, which is to terminate the process. So this is a way that by creating multiple representations and mapping them against each other, we can find errors. I just love this technique. I find this really, really powerful. And isn't that better than building the software according to the first process model than waiting for the phone to ring when somebody realizes there's something stupid? I would just as soon not have those phone calls. All right, so far I've described 18 practices that can help you develop a set of high-quality solution requirements. And once you have those in hand, then what happens? That's where requirements management comes in. This is the subdomain that deals with kind of the care and feeding of how requirements are used on the project and how the project responds to evolving needs. So there are several things you do around requirements management. One is version control, because requirements can change and go through different versions and maybe have to go back to an older version, just as code does. Requirements have a life cycle. They start out being proposed, and maybe they get approved, and then maybe it's ultimately verified as being correctly implemented in the product, but maybe it's deferred or deleted. So there's a life cycle, and we want to track status. If you're serious about requirements management, you'll do requirements tracing or traceability. Which if I was to write a book with 21 practices in it, this would be the 21st. Okay. So there are just two core requirements practices. These are all important, but there are two things that I think every project needs to do. One is to establish and maintain and manage requirements baselines. Okay. And a baseline is simply an agreement among the participants that says, for this period of time, for this chunk of work, here's what we're committing to do. That's all a baseline is. And it becomes the reference then for change management. So managing changes to requirements effectively is the second core requirements management practice. So why is this valuable? Well, it reduces confusion about what people are working on. Okay, if you end up with people working on stuff that wasn't approved for that baseline or was, but then taken out later, those are all ways to waste time. Those are all ways to build products that don't have the quality that you want. And perhaps some of you have experienced the chaos that can result from a series of ongoing, frantic, uncontrolled changes where people are just always racing to keep up and wasting a lot of time and energy and goodwill in that fashion. So what I've tried to do here in our brief time is to suggest to you a number of core practices that I think are really essential on any project around requirements. And I think some of those have a profound impact on the quality of what you build. So thanks for your time. And if you go away with nothing else from this presentation, please remember that without high quality requirements, software is like a box of chocolates. You never know what you're going to get.